I would like to talk about the Valence Bond Theory. Here I will discuss postulates, magnetic property, outer and inner orbital complex, followed by a few questions on the Valence Bond Theory. So what are the postulates is all about? It was first developed by Linus Pauling. The theory basically deals with the complex compound undergoing coordinate covalent bond. During the bond formations, metal ion accept electron pair. Metals will be always accepting electrons pair. Second point. Point number 3, for each metal atom, minimum number of vacant orbitals should be available depending on their number of ligand. In this case, where iron is attached to its 6 NH3 group, needs 6 vacant orbital. Similarly, for copper, it needs 4 vacant orbital since NH3 having 4 groups. So that's why 4 NH3 will be required, 4 vacant orbital. So this is the basic criteria. Point number 4, the metal provides vacant orbital only after hybridization. It cannot be before, it will be always after. And point number 5, the vacant orbital will be overlapped with the ligand, only those who is having the lone pair, containing the lone pair orbital only. Next, point number 6, number of each overlapping is equal to the coordination number of the metal ion. Next, empty d orbitals involved in hybridization may be either n-1d or outer nd orbitals. Okay, so that means if it is 3d orbital is involved, it will be called as inner, while if it is involved nd orbital, then it is called outer. So basically it depends on the inner orbital, means n-1, outer orbital means nd, means 4d. For the purpose of our study, we will consider all the 3d will be as n-1 and it will be inner orbital, and all the 4d orbitals will be nd. Each n-1d orbital participating in hybridizations will be called as inner orbital complex, and each nd orbital participating hybridized metal complex will be called as outer orbital complex. Okay, each one having the inner orbital participations, that is n-1 participation, will be considered as the diamagnetic or paramagnetic, and it will be always called as low spin complex. And each and that one will also be called as low spin complex. What is called points. And next point was that generally outer orbital complexes are paramagnetic, inner orbital are commonly diamagnetic. This is the fact. Now, here if you observed one specific portions where depending on the coordination number, there will be different types of hybridization as well as their shapes will be different. If you observe for coordination number 4, there are 2 types of hybridization. One is sp3 and another one is dsp2, where you have to be cautious on these portions. If it is 4 means sp3, then it have sp3, then it will be tetrahedral. If it is having 4 coordination number, it is dsp2, and thus it will be considered as the square planar. Similarly, For 5 and 6, similarly for the okay. For 6, for n equal to, for condition number 6, the for the seconds. Coordination number, these are the possibility. For 5, it is no need to be concentrate at all, and we need to concentrate at 4 as well as on the 6. If it is 6 coordination number, there will be two possibility of hybridization. One is sp3d and another one is d2sp3. If it is d2sp3, then it is called outer, means 4d orbital will be involved, and it is called as outer orbital complex. Its shape will be same this time, there will not be any difference, it will be octahedral only. And if it is d2sp3, then it will be called as inner, d2 involved 3d orbital for hybridizations, and then it will be called as inner orbital complex. And for that, complex will be so that or shape will be remain same, that is the octahedral, and this one will be called inner orbital complex. So you have to be very cautious on the point number 4, coordination, when coordination number is 4 and when coordination number is 6. Otherwise it will be very simple. For your knowledge, for your memory, I just want to remember you the basic things about on the structure. Here it is the linear, here is the trigonal planar, here it is the tetrahedral. Hope you remember everything. This one is square planar. So for square planar, it can be DSP3 only, DSP2 only, sorry. And for tetrahedral, it should be SP3 hybridized only. For 5, this one will be only and only sp3d or dsp3, and same is only trigonal bipyramidal, there is no doubt about it. But in case of 6 coordination number, it should be dsp3, then this one will be called as inner, or sp3d2. If it is sp3d2, it will be called as outer orbital complex. Shape will remain same, there will not be any issue, so shape will be only octahedral only. Here it is one, and let's consider one example where I am considering 6 coordinated complex of cobalt. So cobalt is having NH3 groups, 6 NH3 group. So due to the presence of 6 NH3 groups, it should provide 6 vacant orbital. First condition is that it should provide 6 vacant orbital. If it is 6 means octahedral. If it is octahedral, we already know that it can be either D2sp3 or sp3d2. So here is our concept. So if it is 6 ligands, that means D2sp3 or sp3d2. So here it is cobalt 3+. Electronic configuration of cobalt will be, since its atomic number is 27, so its general ground state electronic configuration is square bracket argon 3d7 4s2. So when we find out the oxidation number for considering cobalt X, NH3 is a 0 valent ligand, so 6 into 0 is equal to +3. So that means oxidation number of cobalt will be +3. That's why cobalt +3 has to be found out as 3d6 electronic configurations. If it is having 3d6 electronic configurations, when we filled out the orbital, all the 5 orbitals of D will be filled up initially. followed by one electron gets paired up in the very beginning orbital. When it gets excited due to the presence, when it's in presence of NH3 or in octahedral arrangement, it has to provide two orbitals of 3D for the hybridization. Condition is that this condition arises only and only whenever there will be any strong ligand, except 4D and 5D orbitals. If it is 4D and 5D, every ligand will be considered as a strong field ligand only. So here it is. First ligand will become as it is. Second one will be as it is. Third one will be as it is. But the remaining three will be paired up accordingly. So first one will be here, second one will be here, third one will be here. So let's see, if we find out, then two orbital D will be remains vacant. Vacant D orbitals means our purpose is fulfilled. So that is, octahedral complexes must have D2 sp3 hybridized state whenever there is a possibility of strong field ligand. So that means it's a diamagnetic complex. First, it must be a diamagnetic, and due to the diamagnetic complex means there is no unpaired electron. Let's see, here it is, all the electrons are paired up. And even 6 NH3, which will be occupied at, one is here, another paired here, another 3 will be here. So there will not be any possibility of unpaired electron. Without any unpaired electron means it's a diamagnetic complex. Since it involves 3D, that means it should be inner d orbital. And all inner d orbital will be called as low spin complex. So here is the first example. Similarly, if we consider another example where there is a due to presence of one weak ligand, say all the halogens. For example, fluorine. Fluorine is a weak field ligand, and due to the presence of a weak ligand, the electrons cannot be paired up on the octahedral environment. So here it is, cobalt F6, electronic configurations will be cobalt as it is earlier case. It will be same to the earlier one, but here 3D orbital will not be available for the hybridization. So that means only 4s, 4p, and the two 4D orbitals are allowed to hybridize. So this time, which orbital it involved? 4D. 4D means outer orbital. Outer orbital means high spin complex. Okay, so high spin complex. So hence it will be high spin complex. Overlap will be D2 sp3. Sorry, sp3 D2. Similarly, if I consider another example where cobalt having 6 NH3 ligand, only the square portions have to be discussed. Only the square bracket portions have to be discussed. Other parts is not necessary for the discussions of VBT. So here it is, NH3 having 6. Due to the presence of 6, its coordination number is 6. It's a square planar. It's a octahedral complex. Octahedral complex means either it should be D2 sp3 or sp3 D2. Since it's a strong field ligand, so that's why 3D orbital have to be there for hybridization. So means, if you see here it is 8 number 1, 2, 3, 4, 5, 6, 7. 7 electrons are there on cobalt 2+ state. When it gets attached to the NH3, it must have to leave out one of the d orbital, which is actually one electron pair. One is here, unpaired electron, but it have to provide its 3D box to hybridization. So hence the unpaired electron will jump to the 4D orbital to provide to vacant out the 3D orbital. So because of 3D orbital availability of 3D orbital, so it will undergo D2 sp3. So undoubtedly, whenever you will see any strong field ligand, condition is only and only D2 sp3. And simply, it is octahedral complex as earlier. So next is what it can be asked, low spin or high spin? Definitely low spin. That's the way. Diamagnetic paramagnetic. So here it is what? Unpaired electron, one unpaired electron. So definitely it is a paramagnetic one. Similarly for N-nickel Cl4, NiCl4, or for NiCl4, if it is Cl is a weak field ligand, so hence the electron will be remains as it is. There will not be paired up. Okay, there will not be paired up. 3D orbital will be filled up as it is in the ground state. So hence 4s and 4p orbital involved in the hybridization. So result will be what? The result will be an outer. First, it's a outer, low or high. So high structure will be undoubtedly sp3. So that's for tetrahedral. So paramagnetic or dimagnetic, since presence of 2 unpaired electrons, it must be a paramagnetic. Similarly for nickel CO4, so if it is nickel CO4, similarly it is 3D8 4s2. But due to the carbon monoxide as a neutral ligand, so the oxidation number of the nickel will be 0, and hence ground state electronic configurations will be remain same for nickel tetracarbonyl. So here it is 3D8 4s2. On in presence of CO, the 2 electrons of 4s will be jumped to the 3D, since CO is a strong ligand. So due to presence of CO as a strong ligand, nickel's electron on the 4s will be forced to pair up in the 3D orbital. Okay, so providing only 4s 4p for hybridization, and hence sp3 hybridize. sp3 hybridize means it is tetrahedral in arrangement, and ultimately it is a diamagnetic in nature because of our presence of all the paired electron. So that means it's a tetrahedral, the diamagnetic, and sp3 hybridized. Similarly, if we consider another example where NH3 is present, if it is NH3, it says due to the strong nature of its ligand, it cannot be outer sphere complex. It should be inner sphere complex. So hence the unpaired electron will be jumped to the 4p. 4p, since it is strong, so it needs the electron. It needs the vacant orbital at the earlier, just first one. That means one vacant 3D orbital will be available. We'll have to make available for the hybridizations, and hence it will form dsp3 dsp2 hybridizations, and result is a square planar complex. So as I earlier mentioned, the 4D and 5D, if series are there, all ligands will behave as a strong field ligands. So that's all. So what would be the, and I discuss one more example where zinc is considered as the NH3. Hope you have already gone through all, and it will be benefited if you consider it on your own. NH3 is strong, so definitely it will be paired up and for sp3 hybridized. So sp3 hybridized means tetrahedral, no unpaired electrons, so diamagnetic. Now let's come to the questions. Here is one question where it has been asked to find out the square planar geometric complex compounds of the of the given compound. So if I observed it, all the having the 4, so ligand is 4, 4, 4. So that means all the given examples containing higher ligands or stronger ligands. Stronger ligands means it should be sp3 or dsp2. For a square planar geometry, it must be dsp2. Since if we consider Cn and NH3 is a strong field ligand, so nickel on having 4 cyanide ligand will be a square planar geometry, since it can be possible that 3D orbital, a vacant 3D orbital is there, and due to presence of vacant d orbital, it can hybridize dsp2 hybridize, and result will be square planar complex. Similarly for copper, both the copper, the same arrangement can be possible as it is the having same way. So you just do it on your own. So for copper it is 29, so 4s1, 3d1. So on here it is 2 plus, here is also 2 plus, so copper 2 plus, the electrons will be just like similar to the nickel 2 plus, 28. So sorry, 27, and availability of 3D vacant 3D orbital is there, and hence the answer will be the the answer will be the option 4. Here this one asks as follows: the low spin, you have to find out which one is the low spin complex. Low spin complex means there should be stronger orbital should be there, stronger ligand should be there. So if you find out the stronger ligand, in iron, there is the cyanide. Cyanide is a stronger one. NO2, NO2 is a stronger. CN is a stronger ligand. So presence of stronger ligand means inner orbital complex. Inner orbital complex means low spin complex. So hence answer will be answer will be 4th. Here one more questions is there, that for the complex iron's carbonyl complex, what is the wrong? If all the metal carbonyl compounds are organometallic compounds, no doubt in that. And carbon monoxide is a pi donor ligand. Okay, it's a pi donor ligand. We already discussed in the synergic effect. And hence, option 1 cannot be, option 1 is correct, option 2 is correct, option 3, 4 can be correct. Only incorrect is that the complex value of X is 6. X cannot be 6. All the iron carbonyl compounds, X should be 5 only. So pentacarbonyl compounds of iron are possible. So hence X should be 5. So one more question is there. In a complex Ml6 to the power n plus, where manganese is having 5 electron only. Sorry, this one is Mem only. So M has 5 d electrons. So 5 d electrons. So d orbitals have only 5 electrons. So next clue is that L is a weak field ligand. If it is a L is weak, that means high spin complex is possible, or outer sphere complex is possible, or orbital possible for the hybridizations will be sp3d2. So hence 3d orbital will not participate in the hybridization, or feel that d orbital is not participated in the hybridization, and the 5d electron will be part of the crystal, will be unpart of the hybridization, and hence unpaired electron will be present as it is, that is 5. So if it is having 5 electrons, so magnetic property will be depend on all the 5 electrons which are remaining unpaired. So hence D remains as it is, no pairing, and thus 5 will be the unpaired electron, and hence option 2 is the correct. Similarly, one more question was asked. There is a correct geometry, or in case of nickel tetrachlorides 2 minus. So it is 4 minus 4 minus is equal to minus 2. So ultimately nickel is in +2 state. Due to +2 state, it is electronic configuration is as shown above. And due to the chlorine, which is an weak ligand, it will be a high spin. High spin means it should be outer sphere, and hence it will be paramagnetic. And 4s and 4p will be hybridized to form sp3 hybridization. So sp3 hybridization means it should be tetrahedral as the correct answer structure. Nickel tetracarbonyl, nickel chloride Cl4, and nickel cyanide. Diamagnetic paramagnetic. They have been asked which one is the diamagnetic paramagnetic. Diamagnetic paramagnetic is being asked. So if I have to find out diamagnetic paramagnetic, I have to find out which one is the stronger one. If better not to go on the details, just find out whether they are having any similarities of strong and weak field. So undoubtedly CO and CN is a strong ligand, and due to presence of strong ligand, these two will be inner, and inners are always diamagnetic. So that means CO and CN are the diamagnetic. So COCl, Cl, Cn, Cl. So option C is the correct. And all the weak ligands can form high spin complex, which is the outer sphere complex, and outer sphere complex are commonly paramagnetic. Next question was asked about probable found the probable hybrid state for the cobalt atom. Cobalt is in hexafluorocobaltate 3. Ion is found to be high spin complex. So you are being already given that it is high spin complex. Already we know that cobalt, fluorine is a weak, so definitely it is high spin. 6 ligand. 6 ligands means hybridizations will be either D2sp3 or sp3d2. Now, since fluorine is there, it is the high spin, so must be sp3d2. So option will be C. Which of the following system has maximum number of unpaired electrons? D5, octahedral, low spin. If it is low spin, then formation of it will be D2sp3. So that means there should be 3 d orbitals should be remain vacant. Means 5 electron will be paired up. If it is get paired up, then only 1 unpaired electron will be there. So hence it is having 1 unpaired electron. If it is D8, it is tetrahedral. If it is tetrahedral, then it should be sp3. So if it is sp3, that means all the d orbital electron are not participated in the bonding at all. So if it is D8, 5 electron will be single fielded, remaining 3 will be paired up. So that means 3 paired electron and 2 unpaired electrons. So that's why 2 unpaired electron for tetrahedral. Octahedral, low spin, same conformation. See it like this. So it is the 6 D2 sp3. So it is 6. So 6 means 3 paired electron, no unpaired electron. So it will be 0. And if it is D3, undoubtedly this one is the correct option. Sometimes questions may be asked as which of the following systems has maximum number. Here they can ask minimum number. So but otherwise everything will be remains almost as it is. Which of the following does not have chelation? Chelations are those which are the didentate, tridentate or polydentate ligands from a single molecule. Single molecules which are having more than one denticity. So if it is oxalate C2O4, it is the didentate ligand. EN2, it's a didentate ligand. EDTA, polydentate ligand. NH3, monodentate. Means its denticity is 1 and hence option 3 will be the correct. For K3COF6, incorrect statement is, what would be the incorrect statement? Already we have seen earlier that this is the case. This is the exercise we have already done, and here it is another questions of based on COF3 to the power 3 minus. 3 minus if it comes here, then it will be K3. So definitely, undoubtedly, it's a high spin complex. It is true. Cobalt 3 plus means 7 out of 7. It is 3 plus means 4s2 gone. 3d 1 electron gone. So ultimately 3d6. So if it is 3d6, how many number of unpaired electron? Okay, unpaired electron will be 4. So having 4 unpaired electron, it will be 2.4. So primary valency, yeah, this one is the correct answer. This one is the incorrect statement. Since if fluorine 6 fluorines is the inner, so it cannot be possible for ionization. And as you know, primary valency will be satisfied by the negative ligands which can be ionizable. So since negative ligand, that is the fluorine, cannot be ionizable, so hence it's stabilized the secondary valency only. So hence it cannot be 6. So option 3 will be the correct. Which of the following compounds is a square planar and does not have? If you have any doubt on the determining the primary valency, you just go through my earlier video in which I have discussed about the primary and secondary valency or Warner theory. Okay, you just go there. Which of the following compounds is a square planar and does not have any unpaired electron? For square planar, you just carry out on your own. I think you can solve it right now. So it is up to you. And the last question is that, last question for today's discussions, we have to match out the least one with least 2 and which are the common. So first here it's 4, here it is 6. So if it is having 6 ligand, so definitely due to presence of 6 ligand, so it should be octahedral. If it is having 2 ligands, it should be linear. So we have already find out this one. So from least 2, so A in place of A will be common with the B will be with A. So B is A. So here it is A, B, A. So no A is there. So first one option will be our correct answer. Let's say verify it. C should be D. So C should be D. So for us, option 1 is the correct.